When you look at the text-based UI options in Unreal Engine, the most common type that people learn about are text render actors. The first lesson you'll learn when you begin to use these is that text is a lot more interactive in a world space. Game developers are used to this because they must often make text part of the environment, like a stop sign on a street or a billboard on top of a building. An area that you'll immediately want to explore with text renders is the ability to use signed distance field, or SDF fonts. SDF fonts are encoded into their texture sheets in such a way that they take advantage of the texture sampling in the GPU to smooth out the edges. As a result, you can look at a piece of SDF text from a distance of about 2 meters away, and regardless of how close you get to it, the sharpness will maintain. It's a helpful effect because the alternative, where the texture blurs, isn't what a viewer would expect from high-quality text. As you get further away from your text, or shrink it, you will eventually get to the point where letters are affecting fractions of pixels rather than whole pixels. This is the stage of texture minification, which is usually avoided with SDF fonts for quality reasons. It's important to note that this is one major pitfall that can occur with SDF fonts. The distance field math works well for edges, but doesn't work well when multiple edges are within a pixel. You might see very harsh aliasing. The simple distance field shader could be improved to provide a higher quality in this case, but this can add quite some complexity or additional impacts to performance. For magnification, SDF font shaders can provide a sharp edge. There are a few ways to render this. At the bottom right of the content browser, select View Options. Then turn on Show Engine Content and navigate to the Engine Content folder and search for Text Material. Unreal Engine provides materials where you can see the properties of these options. Feel free to copy the content into your own projects. Open Default Text Material Opaque. The following hard-coded -9090 lerp in this text material results in a fairly sharp transition. Let's see an example of using this in a map. Open the C5 lobby map. It's located in Darts, Maps, and then C5 lobby. It's simple and works well for temporal AA. For MSAA, we suggest modifying your content to use a masked material. This way, you still get full shadow casting and receiving, anti-aliasing, high-quality lighting, and per-pixel occlusion. Select the two lights in the middle and set Effects World to True on both. Notice the first one, using the opaque material, is casting a dynamic shadow, and the second, using the translucent material, is unable to cast a shadow, despite cast shadow being set to true. Now, imagine the text you have to render is a time chart at an airport. If you build that up with the text render actors, it will be a huge number of objects, and you run the risk of creating a lot of draw calls with it. But in terms of practical design, you would like to be able to change 1 or 2 of the times on the chart, which would then update the row for that flight, which would then be combined with the other flights. There is hierarchy, and with that, we have a way to keep our code clean, and it's also good for performance. UMG is a modern canvas-based UI system. It creates a hierarchy of all your UI elements, starting with the canvases at the top of those hierarchies. These optimized systems are not the only way to design an elaborate UI, but they have become mainstream with the development of thousands of mobile apps that are almost exclusively UI. When we look at what the Canvas system does, it becomes incredibly useful for a virtual reality world space because the canvas denotes a large texture. For the sake of performance, you don't want to render that texture every frame. Rendering to this texture or render target is contending with your frame rendering. Once that texture has been rendered, it can be sampled by the regular frame rendering and save a considerable amount of time. There are 2 other reasons to consider using the canvas. The first is that after you render the UI to the texture, that texture should be set up to automatically generate bitmaps after the render is done and before it is used in the 3D world. If a sheet of texture has bitmaps available, the bilinear function of the texture samplers properly blend the pixels to the left and the right of the visible range, but the trilinear sampling blends the pixels across bitmaps. Smaller bitmaps are always going to look better when they're further away, and larger bitmaps are going to look better when they're close. Trilinear sampling makes these transitions smooth. Anisotropic filtering made this even more readable when seen from an angle. The canvas of each UMG panel is associated with the texture with quality settings. It's important for this texture to have its mipmap box checked to encourage automatic mipmap generation. A sheet of mipmap takes up the same amount of memory as the original texture. Mipmap textures also often need both the width and the height to be in the power of 2, 512, 1024, or 2048. It's not common to set the resolution any higher than 2048 due to diminishing returns near the display's resolution. The second is that the canvas can be thought of by a 3D artist as a texture atlas. As such, you don't always have to wrap your UI onto a flat plane. People have done a lot of experimentation, texturing, or wrapping a piece of geometry like a modern movie theater screen. You could also take something like a control panel or DJ table in virtual space with lots of switches on different planes, and an artist can lay out the UVs on this table to have parts of the rendered canvas show up at different depths and different angles. This is optimal for VR because it offers a kind of experience that is only possible in 3D. There's one more way to approach UI on Oculus devices: utilizing stereo layers. The engine generates the left and right eye buffers every frame, and these are handed up to the compositor, which properly distorts these images in front of your lenses and conducts the time warp. When you create stereo layers, these layers are also directly applied to the same compositor. The hard part about this is that you'll have to specify whether the layers exist in a fixed virtual world location or if they are going to be a locked layer that moves with the user's head. It is possible to have more than one layer and order them in terms of depth. The real power of this mechanism is that the compositor never misses a frame. Even if your program gets a hitch or is bogged down and unable to render a frame within the allotted frame time of 13.88 milliseconds for Quest and 11.11 milliseconds for Rift, there's a guarantee that the stereo layer will be correctly repositioned in front of your eyes every frame. So this makes stereo layers incredibly valuable for certain applications, like an asset viewer where you can't guarantee the frame rate because of user freedom in VR experiences. They are also particularly helpful if you're in between the loading of levels, where you'll probably have to endure certain frame droppages. Generally speaking, the only way to avoid making the viewer uncomfortable is a fade to black, but with stereo layers, you can fade to other colors or show content during these periods. Next, we'll talk about the solutions that we're going to develop for our game using UMG.